I'm Litt, and as Gene said, I'm a PhD candidate in civil engineering studying hydrologic science, and all of my work is in the Panama Canal watershed. And I originally got involved working in Panama as a Peace Corps volunteer and continued working there as a graduate student here at the University of Wyoming. So where is Panama? It's the land of mass, or it's the mass of land that's connecting North and South America. It's classified as Central America, and most of what I'll be talking about is in this zone right here. This is the Panama Canal zone. You can see this large man-made lake, and that's what supplies water to the canal. So today I'm going to present the scientific problem that my research is addressing, and then go over the study sites and the hydrologic tools that I employ to study these different sites. And then I'll end that with a solution. And so you can just follow these logos along the way and just know where you are in the presentation. So 2016, the canal's operations have been at risk. Just back in March and early April, the canal had to reduce the draft of ships moving through the canal. And so that's how deep the ships can go. And so ships had to become lighter and just not be able to carry as much cargo. And the reason was El Nino. And so El Nino in that region of the world brought less water in the form of rainfall, and there was less water supply to the canal. And just to put things in perspective, an average year in Wyoming, we get about a little over a foot of water in a year. Normally in Panama, it's close to 9 feet of water. And in 2015, to the last El Nino season, only 5.5 feet of water fell. So during this period, water resources were very stressed. And on adding to that stress, in 11 days, the third lane of the canal is going to open up. This has been a multi-year project and may come out to be about $6 billion investment. And it's going to require more water use each day as larger ships move through this bigger, wider portion of the canal that's going to come online. So a common question I get is, why is there a water problem? Don't they have 2 oceans? And yes, that's exactly right. But the way the system works is it's entirely freshwater fed. So we have a central reservoir called Lake Gatun that's 85 feet above sea level. And the way it works is on each side of the canal you have these series of 3 locks, and fresh water is flowing out from those locks to lift the ships up into the central reservoir and bring them across the country. So fresh water is critical for the canal's operations, and that's where my research focuses on. So who manages the canal watershed? And that's the Panama Canal Authority, which they took over the canal management in '99 when the U.S. government handed it over to them. And this is the canal watershed, and green here is forested areas, and yellow is more of agricultural regions. And you can just see about roughly half the canal's watershed is forested in national parks. And so why should we care about the canal's water supply? Well, roughly 20% of U.S. trade with China passes through the canal's locks each year. And even though it's been a $6 billion investment to expand the canal, roughly $15 to $20 billion are being invested along the eastern seaboard to expand port capacity for these larger ships that will start moving through the canal. So this is also an economic advantage to the U.S. that we have secure shipping operations through the canal. And so my research question, it gets at how does land management influence water supply in the canal watershed? And so I look at forests, pasture, tree plantations, and also a mix of these different land covers. The reality is most private land is a mixture of agriculture and forest. And so I study these different land covers and see how they differ with water supply. And so I'll just go through the different land covers. Forest, roughly half of the watershed is forested, and this is through the national park system that the country has in place. Tree plantations are becoming very popular. They've been a major form of investment from international forestry companies, and this is happening on private lands. Ranching is also a very culturally important activity for local Panamanians, and there's a lot of ranching activity as well as other agricultural practices in the region. And then mixed land use, and so this can be anything from slash and burn crops to pasture and maybe some forest in there as well that's growing set aside land. So I study that as well. And so now I'm just going to talk about the tools that I employ as a hydrologist to study these different land covers. And so I use stream flow and rain gauges. That's the bread and butter of a hydrologist, knowing how much water comes in and how much water flows out. I also use geochemical tracers, and that lets me identify where water is coming from. And so in this example, I use tracers that serve as a fingerprint to know where rainwater is coming from and groundwater is coming from. This is a storm hydrograph. It represents, in the x-axis, this is time, and the y-axis, this is the amount of stream flow. And using tracers, I'm able to say the green line is how much of that stream flow is rainwater, the blue line is how much is groundwater, and the two of those combined is the total amount of water in the stream. And generally, just a little fact about forested watersheds around the world, roughly half of that water that you see in the stream during a storm is groundwater. It's not all rainwater when you see a flood like that. So. And a third technique I employ is geophysical imaging, and this is using electrodes and current to visualize water that we rain down onto a plot and watch it move through the soil column. And in this example, you can see the yellow color represents dry soil, and the green to blue is wetting soil. And just to summarize my results, we find that using the mass bounds of rain and stream flow out, we see that the forest works as a sponge, and it holds on to water during the wet season and releases water more readily during the dry season. We also find, using geochemical tracers, that stream flow is most sensitive to deep groundwater in the forest. So how much water is stored in that forest is going to influence how much water is coming out in the stream during the dry season. And then looking at different land uses, we see a very strong contrast between forest and pasture as to where the water is moving. And so it's a really great contrast in these two images. You can see water is infiltrating down deeper in the forest, whereas it's staying near the surface and more readily running off to the stream in the pasture. So to summarize, trees help store water, but roughly half the canal's watershed is private land agriculture. And so how can we secure the future of the canal's water supply, given that so much of the land mass is privately managed? And so the solution kind of comes into economics. And so I work with a group of economists that are trying to value the value of the land and the perception that the landowners have on the value of their land, and what it would take to value the water and to develop a system of payment for ecosystem services. So the way this works is the Panama Canal Authority has a value for added water. They could pay a landowner or compensate them to switch from one land use to a potential water conservation practice on their land, much like a conservation easement program, which we're familiar with in the US. And not to take off my scientist hat and get back into what I worked in as a Peace Corps volunteer, I think one possible solution to this could be a silvopastoral system. And this is a combination of grazing and agroforestry, where you're growing trees on the land as a dual use of the land. And it can increase landowners' income considerably, since tropical hardwoods generally have more value than beef. But it also allows the short-term investment income from selling off beef. And so, to just summarize, to wrap up, some possible solutions for success. This payment for ecosystem services framework can only work if the value of water added from a conversion of one land use to another is worth it as far as the hydrologic benefit. If you can get enough water, say switching from pasture to agroforestry. In this framework, there need to be participants on all levels and community involvement, and it could ultimately lead to greater economic advantages for the general population of landowners throughout the region. So with that, I'd like to thank David and Jade Walsh through the Center for Global Studies for funding much of my latest research, and much of my former research was funded through the National Science Foundation and conducted under the auspices of the Smithsonian Tropical Research Institute. Thank you.